This is AP Buffer Problem Set 1C. I bet when you saw pure water, you were like, oh, well, I know the pH is 7, which is absolutely true, but there's actually a chemistry way of doing this, which I will show you. Probably way easier than the other ones. However, if you look at your water, it's going to dissociate into H plus and OH minus. Now, if I write my equilibrium constant, it's going to be called Kw because it is water. It's H plus times OH minus. It's not divided by water because pure water, you know, is a liquid. And I know that Kw happens to equal 1 times 10 to the negative 14th. Well, if I'm trying to find out the H plus, I know that both of these are going to be equal. So for every water I make the same number of H pluses and the same number of OH minus. For example, if I had 5 waters, I'd have 5 H pluses and 5 OH minuses. If I had 10 waters, I would have 10 of each. So if I call this X, what I have is X squared equals 10 to the negative 14th. So when I square root that, I get X is 10 to the negative 7. What that means is both H3O plus, or H plus in this case, it really means the same thing. If you had done 2 waters, you would have dissociated into H3O plus and OH minus. It means the same thing. Equals OH minus, and they both equal 10 to the negative 7. So pH is simply negative log of the H plus concentration. So now I type that into my calculator, which I don't even have to do. It's negative log of 10 to the negative 7, which I happen to know is 7. So that gives me a final pH of 7, which is neutral, which makes perfect sense, and that would probably be the answer that you would just guess, but here's the actual chemistry way of figuring it out.